Hi, the doctor said, Dr. LB, and I'm here to help you through your math difficulties. We take a look at inverse functions today. So, if f and g are functions such that f of g of x is x and g of f of x is x, then the function g is the inverse of f and is denoted by f with a superscript of -1 of x. That's read the inverse of x. So, one way that we can verify that two functions are inverses is that we can do composition both ways to see if we indeed get x back. So let's look at f of g of x and see what happens. So we write our f of x function, and wherever there's an x, put a set of brackets. Then we're going to slip in our g of x function. And when we simplify, we have x plus 9 minus 9, which is x. So let's look at g of f of x. So I write my g of x function, and wherever there's an x, let's put a set of brackets. And then I am going to insert my f of x function there. So in my numerator, the 9's will cancel. I have 5x divided by 5. So my result is x. So we have just verified that f and g are inverses because composition both ways yield x. So we have the horizontal line test. Now this horizontal line test lets us know if a function has an inverse that is also considered to be a function. So if a function passes the horizontal line test, then it is 1-to-1. So a function that passes the horizontal line test means that you have a function that no horizontal line intersects at more than one point. Let's look at an example here. We have, this is the graph of a parabola that's pointing downward. If I draw a series of horizontal lines, notice that on that particular graph, these horizontal lines touch the graph in more than one spot. So, does this function have an inverse function? No. If I look at this one, this is the cubing function, and I graph a series of horizontal lines. Each horizontal line will touch the graph in only one spot, so I can say yes, this graph has an inverse function. So how do we find this inverse function? Well, number one, you need to verify the function is 1-to-1 or it passes the horizontal line test. 1-to-1 means for every x you put into the function, you get one unique value back. So once you have verified that the function is 1-to-1 or it passes the horizontal line test, then you want to replace f of x with y. Next, interchange x and y. Then next, solve for y. And then replace y with f inverse notation. Now, the last step you can do or not do. If you want to check your work, you can verify that f of f inverse and f inverse of f both equal x. Now, this is typically not required, but it is a way to check your work. So let's find the inverse of the function f of x equals x squared minus 4. Now, if we look at the graph of just plain old f of x is x squared minus 4, then that's the graph of the f of x function 4 units down. So it's going to look like this. Now, that does not pass the horizontal line test. But if we restrict the domain to all x is greater than or equal to 0, then we're now looking at the purple portion of this graph. And that portion will pass the horizontal line test. So yes, we can find the inverse of this function. So we have f of x equals x squared minus 4. So the first step, you replace f of x with y. Then you interchange x and y. And then you solve for y. So let's get y squared on one side by itself by adding 4 to both sides. And then we can take the square root of both sides. And we only need the positive square root because we restricted the domain so that we would have the positive values. So we have the inverse of f is the square root of x plus 4. So next, find the inverse of f of x equals x cubed minus 1. Does this pass the horizontal line test? Well, yes, it does. This is the cubing function down 1 unit. So yes, it will pass the horizontal line test. It is a one-to-one function. So let us find the inverse. So we replace f of x with y. So we have y is x cubed minus 1. Then we interchange x and y. So we have x is y cubed minus 1. Then we solve for y. Well, I can add 1 to both sides. So y would be the cube root of x plus 1. And then I need to put in my f inverse notation, the cube root of x plus 1. So next, we want to find the inverse of a form of the reciprocal function. Now, the reciprocal function is 1 over x, but this is also a form of it as well. And for every x that we put into this function, we will get a unique y value back. You won't be able to put two different x's and get the same y value back for this one. So this function is one-to-one, and it does pass the horizontal line test. So let's find the inverse. So we replace f of x with y. So we have y is 2x minus 4 over x plus 3. Then we interchange x and y. So we have x is 2y minus 4 over y plus 3. Now we need to solve for y. So we are going to multiply both sides by y plus 3. Then we're going to distribute. We have xy plus 3x equals 2y minus 4. And then we need to choose a side to get our y's to. Okay, so I am going to take xy over, and I'm going to bring the 4 over. So I'm going to take this over here. I'm going to take that over there. And if I do that, I am going to have 3x plus 4 equals 2y minus xy. Now you want to gather your y terms on one side so that you can factor out a y. And then you can divide by whatever that is, 2 minus x. So you have y equals 3x plus 4 over 2 minus x, or f inverse of x is 3x plus 4 over 2 minus x. Now, the graphs of f of x and f inverse of x, it is a reflection about the line y equals x. So what that means is that if a point 2, 0 is on one of the functions, then the other function you have 0, 2. So if AB is on the graph of f, then BA is on the graph of f inverse. It's a reflection about the line y equals x. That's called y equals x is the identity function. So remember that Dr. LB is always in. Please come back for more math help.